So in Green's theorem, let us first consider some region in xy plane and consider a vector f, and that vector f is represented in this form: p, that is function of xy, x cap, q, function of xy, y cap. So that is a two-dimensional vector field in xy plane. And also consider a region R in xy plane, and that region is surrounded by this closed line. So C is the boundary of that region, oriented counterclockwise. So this direction is, I have taken counterclockwise. You know that I have written this statement, same statement I have written in Stokes theorem. So line integral of f around boundary of R is same as double integral of the curl of f within that region R. So you can see, you know this statement. Now from this statement, we have to write left hand side and right hand side. So let us first see what will be f dot dl. How you can write f dot dl? dl is dx x cap. You know that you can write dl is dx x cap plus dy y cap. So this can be written as p xy dx plus q function of xy dy. So this is f dot dl, and we have to see right hand side. So what will be del cross f? Let us first find del cross f. From given f, you can find the del cross f. So del cross f can be written as, if you expand this, you will get del cross f is z cap del q by del x minus del p by del y. You can easily expand del cross f. So you will get this term. And what will be dA? In xy plane, you can write this as dx dy z cap. So we can write del cross f dot dA. This integral can be written as del q del x minus del p dy dx dy. So finally we can write this equation as, this is the closed integral. Let us see counterclockwise. C, this is anti-clockwise. You have to move in anti-clockwise direction. And this term will be p xy dx plus q xy dy, and that will be same as, you have to find surface integral over the region, and that will be del q del x minus del p del y dx dy. So whenever you have to find left hand side, normally you have to find this closed line integral. So function p and q will be given. Then using Green's theorem, you have to just find right hand side, and you will get this integral. So this direction will be either anti-clockwise or clockwise direction. So in anti-clockwise direction, you have to take positive sign. But if you have direction is clockwise, if direction is clockwise, then you will get a negative sign also. So that is the statement of Green's theorem. So now we will see some examples on Green's theorem. So first example is, you have to evaluate this integral C, and this is given as x square minus y square dx plus 2xy dy, and the curve is boundary of region R, and that region is given by xy. So x lies between 0 to 1, and this y lies between 2x square to 2x. This is the region. So evaluate this integral. So let us evaluate this integral. So you have to show the region x and y. So y is equal to 2x square to 2x. So y is 2x square will give you parabola, and y is equal to 2x will give you a straight line. So you will get a parabola and you have a straight line. So you have to see anti-clockwise direction, and limit of x will be maximum up to 1. So what will be this limit? This is y is equal to 2x square line, and this line is y is 2x. So this is the reason. So this will be 2. You can easily find this y will be 0 to 2. So you know the reason. Now you have to use Green's theorem. This is,
सर
yes,
सर ये पैराबोलिक कैसे बना सर?
y is equal to 2x square,
ओके सर.
and this is y is equal to 2x, and you have taken this as anti-clockwise direction. So you can first compare with this. What is p? What is p here? P is x square minus y square. And what is q? 2xy. So now you have to find del q del x. This will be 2y, and what will be del p del y? This is minus 2y. Okay. So now this integral value will give you, right hand side will be, you have to see right hand side. Del q by del x minus del p del y dx dy. So what will be this? This is 2y. This is 2y and minus of minus 2y dx dy. So what will be limit of x and y? So x varies from 0 to 1 and y varies from 2x square to 2x. Now evaluate this integral. Evaluate this. So this will give you x 0 to 1. This is 4y. So 4y will give you 4y square by 2, 2x square to 2x dx. So this will give you x 0 to 1. This is 2y square. So that will give you 8x square and minus of 8x power 4 dx. Because y square will give you 4x square and this will give you 4x power 4. So you can easily integrate this. This integral will be 8x cube by 3 minus 8 x power 5 by 5. Limit is 0 to 1. So this is 8 by 3 minus 8 by 5. So what will be this value? This is 16 by 15. So this value will be 16 by 15. So let us see another example.
So what was the question? What are we proving here?
You have to find this integral value. This integral value is given p dx q dy. You have to evaluate this integral over the region. So using Green's theorem, you have to calculate it right hand side. You have to evaluate the integral, this integral. So according to Green's theorem, just find this value, that will give you same result. Again evaluate this integral. X dx minus x square y square dy. You have to evaluate this integral. And this region is specified. What is that region? This is the region. You can see this point will be, this point is 1 0, and this point is 0 1, and this point is 0 0. Again you have to move in anti-clockwise direction. This line is y is equal to x, and this line is y is equal to 1. So over this boundary, evaluate integral x dx minus x square y square dy. Please evaluate this. So again, this is p and q. So p is x and q is minus x square y square.
हेलो सर
Yes.
सर ये जो आपने फर्स्ट लाइन लिखा है बाई एक्सिस पे सर ये कैसे है सर एक्स स्क्वायर बाई स्क्वायर वाली टर्म सर
This is given. This is given.
यस सर
This region is specified. That will be always given. I have told you in xy region will be given. You know the boundary also, and whether it is clockwise or anti-clockwise. Then you can evaluate this. So what will be p here? P is x and q will be minus x square y square. So del q by del x. This will be minus twice x y square, and del p by del y is 0. So now we can evaluate this integral. Integral del q del x minus dx dy. Is minus of 2xy square minus of 0 dx dy. X varies from 0 to 1
0 to 1.
and y varies from y is equal to x to y is equal to 1. So evaluate this.
So y के limits कैसे?
So let us see, if you integrate with respect to y, so x 0 to 1, So y will give you minus of twice x y cube by 3, y is equal to x to y is equal to 1 dx. So if you substitute this, this will be x 0 to 1. So this will give you, what will be this value? Minus twice x by 3 and then minus twice x power 4 by 3. This will be plus sign. Put y is equal to 1 and then y is equal to x and integrate this. So this is minus 2 by 3 x square by 2 plus, I think this is 2 by 3.
3.
So this is 2 by 3 x power 5 by 5. Limit will be 0 to 1. So if you put these limits, you will get this value will be minus 1 by 5. Please check it. Now see another example. Again, you have to evaluate 2y dx minus 3x dy. So what will be this integral? And now you have a circular region. In xy plane, you have a circular region, and now this direction is, let us take it as clockwise. Take it as clockwise. Take it clockwise. This is the region R, and equation of the circle is x square plus y square is equal to 1. Let us calculate this integral. This is now clockwise. So P is 2y and Q is minus 3x. So del Q by del x is minus of 3 and del P by del y is 2. So in this case, since direction is clockwise, you have clockwise direction. So right hand side will be with minus sign, minus of this value, del Q del x minus. You have to calculate this with minus sign for same integral, because this is clockwise. So calculate this with minus sign. So this will give you del Q by del x is minus of 3. This is minus of 3 and then minus of 2 dx dy over this region. So minus minus plus, you will get 5 dx dy. So what will be this integral? This dx dy will give you area of the circle. Simply it is dx dy is the area of the circle. So radius is 1. So what will be area? 5 into pi r square. So this will be 5 pi. Let us see another example. x and y. So take, this is 0, 1, 2, 3, 4 and 5. So 1, 2 and 3. So you have this region. And again, this is the semicircle. This path is semicircle. This path is semicircle. So you have to consider this region. Again in anti-clockwise direction. So write down the closed curve C forms the boundary of region R shown in the figure. The region R is the area enclosed by the union of 2 cross 3 rectangle and semicircle of radius 1. Semicircle of radius 1. Then find,
It should be 3 cross 4.
this is 2 cross 3. This unit is 2 and this unit is 1, 2, 3. You can see unit, that is, this length is 2 and this is in 3 units. Then find the line integral. Let us find the line integral C x dy minus y dx. What will be this integral?
So 12 plus 2 pi or pi?
Let us see the solution. You have to find closed x dy minus y dx. So you have to first express in this form. So that it means you can write this as minus y dx plus x dy. So this will give you p is minus y and q is x. So del q by del x will give you 1 and del p by del y will give you minus 1. So what will be this integral? Del q del x minus del p del y dx dy. So this will be 1 minus of minus 1 dx dy. So that is 2 times integral dx dy over this region. So you have to find area of this region. So what will be area? So area of the rectangle plus area of the semicircle. So what will be area of the rectangle? 2 into 3 plus pi
Pi r square by 2. R is 1.
pi r square by 2. So this will be 12 plus pi. So this is the answer. Answer is 12 plus pi.